Well, hello everyone. My name is Peter Danleev. I work for the University of Oxford and I also work for the Alan Turing Institute in London. That's the National Institute for Artificial Intelligence in the United Kingdom. I'm not going to talk much about myself. If you type my name in any internet browser, you're going to get a lot of information about me, including my University of Oxford staff profile and my Alan Turing staff profile. Please feel free to connect if you find that appropriate. I wanted to talk in this presentation about the book that I've recently published, and the Chinese edition is coming soon in the first quarter of 2026. It's going to be published by the CITIC Press Group in China. In that book, I talk about three key enabling technologies that are going to change not only the financial ecosystem, but the society as a whole. And these three technologies are bringing benefits, but also risks. Now, in terms of the benefits, if we talk about how AI is hugely overvalued at this present moment, stock market is pricing artificial intelligence technologies as something that needs to produce around 2 trillion in economic value. We don't really see that kind of a turnover, not even from the top 6 world leading companies in artificial intelligence. That means that we're betting on the future return from these artificial intelligence technologies, but we haven't really seen that much of a real output today. I'm not denying that artificial intelligence is going to be extremely helpful in the future. I'm just saying that today most of that value hasn't really been materialized, and we're overvaluing these kind of services that they come. But we don't really talk enough about the new types of risks that they come from the combination of different types of technologies. So if you're not familiar with the term technological singularity event, I'm going to cover that very briefly in the next few seconds. This is a definition from 1970s, and it refers to the concept of singularity as a hypothetical future event where technology grows out of control and is irreversible. It is often associated with the idea that machines will surpass human intelligence, leading to a fundamental societal change. So let's talk about that a little bit in today's terms, not in 1970s. So let's look at where do we stand. As you can see in this slide, I'm comparing the various capabilities of artificial intelligence related to human performance. Remember the word capabilities, because on the next slide, I'm going to talk about benchmarks. What does it mean, capabilities? It means reading, image recognition, language understanding, speech recognition, general knowledge tests, code generation. And as you can see from this slide, actually, let's look at this in the more interactive version. And so this is the open source diagram that you can see from our world in data, but also there's a more interactive place. So I can share all these links with you. Just feel free to connect with me and I will send you the links. And here you can pick and choose which specific capability you're concerned about. So if we talk about the math problem, we can see that the AI is not that far from achieving human level intelligence. The black line here is the human level intelligence. And when we look at the overall test scores on human capabilities, we can see that AI has already overtaken human capabilities in many categories. And since 2020, that upward curve, it goes only in a flat line, which means that AI is taking over human capabilities at a much faster pace than it was back in 1950s when artificial intelligence was invented. So now let's look at this singularity event from a more graphical representation, not only from the definition from 1970s. Let's see, what does the singularity event means. Singularity event refers to the human intellect, how it develops gradually, step by step, in a very controlled and reliable pattern. But since 1950s, when we created artificial intelligence, we can see that the red line, that curve, has changed and it doesn't grow at the same speed as the human intelligence does. Now, we can debate if artificial intelligence has already crossed that line of overtaking human intelligence or not. According to the benchmarks on capabilities that I showed you, in many capabilities, machine intelligence has already overtaken human intelligence. But let's talk about what's next. In the few slides that are ahead, we're going to talk about transhumans, when we connect human brain to a machine. And there's expectation that this will flatten up the curve, that humans would be able to develop at the same speed as the machine. That is incorrect. Now, in the book, I'm showing you statistics that show that artificial intelligence in the future is going to be more like the curve like this, especially when we develop the quantum computer, which is going to enable machines to process data at speed that we have never seen before. So, transhuman intelligence might enable us to catch up for a short period of time, but the machine will take over eventually. Going back to the slides, now, we looked on the previous slides the capabilities, human capabilities, reading, reasoning. Now, let's look at the benchmarks that we have been measuring since 1998 to 2024. As you can see, we have the same black line, that's the human level intelligence. As you can see here, machine intelligence has already crossed that black line in many of those benchmarks. And whatever remains, the curve is going flat up in one specific direction. So what are we measuring in these benchmarks? We're measuring mathematical reasoning, we're measuring computer vision, measuring speech recognition, natural language understanding, general language model evaluation. So I showed you two different statistics that they show very clearly that human level performance has already been overtaken by the machines. If you want to read the full report, I will provide you access. This is from the United UK government, the interim report, and this is also open source available graphs and diagrams of this image. This report is 132 pages. The most important image is this, because it shows you the result of the analysis. Also, the test scores that I showed you are from 2023. Artificial intelligence has already overtaken human level intelligence in many of those benchmarks. If you want to read more up-to-date report, this is the artificial intelligence report from 2025. This is published by Stanford University. It consists of 457 pages, and it's only going to be valid for the next 2 or 3 months, because in the 2026 we're going to have a completely different report which is going to show you different results. So that's why I only showed you the test scores and the interesting part, because that figure will change in the next few months. Going back now to the slides and talking a little bit more about how this is going to change the element where it's irreversible. Because remember, the definition technological singularity refers when artificial intelligence is taking over human intelligence and propels with the speed of upward category that is also irreversible. So what is going to make this irreversible? Well, traditional artificial intelligence that I showed you is based on statistical models. The first statistical model that we developed, that we used for artificial intelligence, was developed in 1805. That's long before we actually had a computer. So we had artificial intelligence before we had computer. It was a simple statistical model. And since 1805, we have been feeding data manually, even before we had computers, to artificial intelligence. Nothing has escalated, because traditional AI, it's comparable to a train on a train track. It runs with a very specific and predictable pattern. Agentic AI is more comparable to an autonomous vehicle that drives and makes decision to turn left and right autonomously. So the autonomy is here the problem, because once we have autonomous systems that make decisions for us, we lose the control, and that makes it even more irreversible. This diagram will take way too long to cover in 15-minute presentation to explain, but we need to remember just one thing, that securing agentic AI is not the same like securing traditional operating systems. We need to start from the data source and all the way to the agentic execution. Why? In the book, I'm giving you an example where you can just manipulate the data with 0.001 of a percent, or in decimal point at 0.0001. That is the only deviation that you need to change in the data in order for the model to be misaligned. And here is the key catch here. Most academics, they still don't get it. They think that it's about the model security. It's not. We can secure models eventually, and if we cannot secure them, we'll risk manage them, like many other things that we do in our society. Problem is that you can orchestrate. The orchestration of very different models, that is the problem. Now, as I said, that's really long discussion that I won't be able to cover in 15 minutes presentation, because we are already at the 10th minute still talking about artificial intelligence. let's move to the blockchain technology, the good, the bad, and the ugly. Why is the blockchain technology good? Since 2009 that we invented the blockchain technology, nobody has been able to break the blockchain itself. They have been, we had hacks on the digital wallets, we had hacks on the bridges, we had hacks on oracles, we had many hacks, and much money has been lost from the blockchain cryptocurrencies. But the blockchain per se has never been hacked, which means that it's a reliable and battle-tested technology that we can use in financial systems for transactions or for creating a ledger that cannot be compromised. What is the bad thing? Well, the bad thing is that sometimes this creates different types of risks, and that might not be as desirable. Now, imagine a scenario where the transparency is not what you require. Financial transactions are quite often non-transparent. So if you have a cryptocurrency based blockchain that is fully transparent, you can trace the very first transaction on Bitcoin or Ethereum. And privacy, it's a little bit problematic, because even if it's just a simple hash, you can connect those hashes to names. And I have demonstrated that in the book, how it can be done. What is the ugly part about blockchains? Blockchains per se means that you lose the control over it. It's decentralized. You don't have control. Centralization is cloud-based technology. Blockchain is decentralization. Once you lose that technology, this builds up on the promise of irreversible artificial intelligence, where AI is combined with the blockchain, which that means that it becomes decentralized. And as the feds have tried many times with the bitcoins and different cryptocurrencies, they are very difficult to shut down, because even if there is one single computer node based in a basement in Kazakhstan, Turkmenistan, or in Ohio or in Montana, you cannot find every single computer node and shut them down. As long as there is one computer node running, the system is alive. Now, compare that with artificial intelligence that has gone rogue because somebody has been manipulating the data, poisoned the data with 0.001 on one specific agent that has propagated. So now you have reinforcement learning loops that they're reinforcing the training patterns with a misaligned algorithm, and is decentralized and out of control. That's a problem. A second problem that we have with blockchains is we can learn from the experiences from the cryptocurrencies. Even though they are illegal in China and in the United Kingdom are considered as very much as gambling, we can learn from those experiences when we build our system. So one lesson that we need to learn is, let's talk about the very first transaction that Satoshi Nakamoto made to Han Finley. Now, if you're not familiar with this story, Satoshi Nakamoto disappeared after inventing Bitcoin, and we have never heard from him since then. So Satoshi Nakamoto is a mysterious figure that we don't know who is he or if he is alive, but we know that Han Finley is not alive. Han Finley died from cancer. He sold all his Bitcoins for his cancer treatment, and eventually, sadly, he died. And we don't know if Satoshi Nakamoto might be dead as well. That leaves an open question. Many of the wallets that Satoshi Nakamoto created are currently obsolete. They're vulnerable. But we don't have control over it because the system is decentralized. We don't have the private keys in order to shift that funds to whoever is his inheritor. So usually if you have money, your children will inherit that money. With Satoshi Nakamoto, there's loads of money now that is in his wallets. We cannot shift that money, and the wallets are vulnerable. Once we have a quantum computer would be able to break those digital wallets from Satoshi Nakamoto and drain all the funds within few seconds. So now the question is, how many digital wallets do we have that they're vulnerable? Well, this is a whole list of obsolete digital wallets that we have no control over it, and they are vulnerable to quantum attack. So this is another type of wallet that is also obsolete. That hopefully explains why decentralization brings security but also brings risks. And now let's move on to the final part of this presentation, is the quantum computer. China has been one of the leaders in developing quantum computer. China Telecom has already deployed a commercial system that combines post-quantum cryptography with quantum key distribution, and China is building national standards which would be competitors to the NIST standards. Many people think that we have to adopt the NIST approved post-quantum cryptography standards. I actually disagree. I think competition is beneficial. So we need to have competition in order to have better post-quantum cryptography algorithms. And it doesn't mean that the NIST approved, the National Institute for Standards and Technology in the United States has approved the standards already. It doesn't mean that they will stay the same. As new vulnerabilities show up, those algorithms will change. So this is going to be an ongoing process that we're going to have to keep updating with time. And on that note, let's look at the case of RSA and why I think that quantum computing will become a bigger problem than what we see today. Recently, I had an interview with a journalist, and journalists, they have story in their mind that they just look for experts to support their narrative, even though their narratives are sometimes factually wrong and incorrect. And that's why I wanted to make this clear. There are three countries that are probably going to develop a quantum computer based on the money that they're investing in it. China is investing 5 times more money than the United States. China is investing 15 times more money than the United Kingdom in developing a quantum computer. So naturally, you would think who is going to develop the first quantum computer? It's probably going to be China, if not China, US, or the third country would be the United Kingdom. But it's going to be one of those three. And then there's a risk of what we call time travel attack or store now, decrypt later type of attack. That means that adversaries are storing the data that we're transmitting now that is encrypted with RSA or ecliptic curve cryptography. And once we have a quantum computer, the quantum computer would be able to break that and read the information from those transferred files. Most people associate this with a risk with a nation state. It's not. I've never said that it is. I think nations usually behave rationally and reasonably. China is not going to do some significant damage to the US, even though they have trading disagreements and disputes at some point. That is not a reason why China would trigger something like that. Now, a hacking group, on the other hand, might, because hacking groups, they make money from hacking. From coming from a red teaming background, I work in attack and penetration. I can tell you that most of the hacking organizations pay their bills, their electricity bills, their salaries from the money that they make from hacking. So who is going to use this quantum computer to decrypt data that is of some value? It's going to be the hacking groups, regardless of which country they are being based. So we need to pinpoint our guns to protecting ourselves from the hacking groups, not from nation state. And here most people would say, well, if only China, US, and UK has this technology, then clearly hacking groups won't get access to that. Let me explain this differently in more technical terms. The case of RSA. The RSA is one of the algorithms that we use to encrypt our data in transfer. RSA was published in 1977. That's in the US. United Kingdom developed a parallel algorithm in 1973. So there is usually some key enabling technology that was developed beforehand that would enable the development of that new technology. That's the difference between the UK and the US developing the same algorithm independently, not working together. It's just top secrets at the time. So they would develop the same algorithm within 4-year difference. That means that every time we develop a new technology, we can expect to have a short gap before many other organizations are able to produce that, even if they've never worked together, because of the enabling technologies that would enable the development of that specific technology. So remember this. There's an enabling technology that would enable the development of a quantum computer that would make everybody be able to develop a quantum computer with a short few years time in between. That means that many of the adversaries would also be able to develop a quantum computer, and they are storing data now that we are transiting that they would be able to sell for value at a future date. How much of that data needs to be encrypted with post-quantum cryptography? Very small percentage. Not even 1% of all the data that we transmit would actually have a value in 10, 20, 30 years time when we have a quantum computer. Most of the data that we store today would be valueless. So there is no point securing valueless data for future quantum computer because it will have no value. You need to focus on that 1% of the data that would be shares bonds that would still exist in 20, 30 years' time. And if you're not encrypting that with post quantum cryptography, you're exposing that financial data to a significant risk. The same like we cannot secure the digital wallets from Satoshi Nakamoto because we don't have access to the private keys. Those will remain vulnerable even when we have a quantum computer, and the funds would be lost, leading to a probably significant downfall of the Bitcoin. Now, if this is not convincing enough, let me give you a second example why, when technology is developed by one nation, country, other countries and organizations will be able to absorb that and develop competitive products. Let's look at the transformer model architecture. So here we have the transformer model developed by Google scientists in 2017, 2016, 2017. They don't work for Google anymore. They did at the time, but they developed a transformer model architecture. The year after, the 12 months later, OpenAI came up with the transformer architecture that constitute the very first GPT, OpenAI. Now, you see that when one technology was developed by one organization, other organizations have been able to reproduce that at a speed. And now think how many transformer architectures we have: DeepSeek, Grok, OpenAI, Gemini. These like various different technologies. Each country now has its own transformer model architecture, which leads us to think once we have a quantum computer, it's almost inevitable that other organizations and countries would be able to reproduce that technology because one, the enabling technology that has enabled to fix us the quantum computing error, for example. And then once we have that one technology, other nations would be able to reproduce the same technology. And that means that the hacking groups would be able to reproduce that quantum computer, break into these data files that we're storing today, that they're not encrypted with post-quantum cryptography, and steal all the value from those files. So on that note, let's look at how do we actually see the development of artificial intelligence in terms of society, not only finance. And quite often we think about the risk and benefits as statistical relationship between one key element, but that is wrong. So artificial intelligence might be beneficial in terms of finance. It might cause significant disturbance in job losses and other sectors. Let me just demonstrate why in terms of health we should not see the problem as one specific problem as the overall issue. Let me give you some specific examples. Most people talk about homicide in the world, that's murder. But actually, if you look at the statistic, more people die from suicide, not from homicide. So there's very little help to helping people with mental health problems. There's also a lot of talk about drug disorder or alcohol disorder or various different addictions. But actually, most of the deaths in the world happen from cardiovascular disease, cancers, respiratory disease, diabetes, that's sugar over. So as you can see on the upper level here, most of the diseases that they happen, they're not actually the ones that we worry too much about. If you look at terrorism, that has only 0.03% of the annual number of deaths. Cardiovascular disease is a bigger problem. Now, what is the relationship between cardiovascular disease and smoking? That would be a different statistic to show. But if we're looking at how artificial intelligence is going to impact one specific category, we also need to look at the sideline effects that would be triggered by artificial intelligence. And how do you prevent from artificial intelligence being developed for some evil things that won't really help society? Well, you can invest in technologies that we're connecting this to the transhuman intelligence from the first diagram at the beginning. Let me just go back to that slide. So we talk about transhumans, and here we have an example of how digital technologies would enable people with disabilities to interact with our environment. Well, this is not that far from transhuman, because if you look at what Neuralink is doing, this is exactly what Neuralink is doing. They're trying to connect people with disabilities to interact with machines. But if we look at this purely from the perspective of helping people with disabilities, that kind of technology usually doesn't prevail, doesn't break through because there's no financial incentives. If we can connect this to the link that artificial intelligence will take over humans unless we build this kind of technology for transhumans, we're enabling these people with disabilities to interact with our environment, but also in the same time we're building technologies that would help us with financial planning. Virtual reality enables various different technologies like Tai Chi or dancing. My research in the past has focused on dancing as a mental health therapy, which we could enhance with virtual reality machines and artificial intelligence agents that would act as community. Social media in the past worked in a way that is not happening at this present moment. Social media has changed. In the past, social media worked like teenagers were taking pictures of their lunch and posting them on the internet, or making funny facial expressions, posting them on the social media. That has changed. Teenagers don't interact with social media that way anymore. Teenagers interact very much with groups, silos. It's almost impossible to see a teenager now posting pictures on Instagram or other social media platforms of their lunch. They create groups, communities that they support a narrative that they see. Now, as you can see here, if that is a dancer interacting with a dance group, that could be positive. But if groups of people are interacting with narratives that they are conspiracy theories, you could see how that would build more mental health problems for our society and how society would suffer. We need to enable community groups that are based on more positive things that would also bring financial value, because you could sell a virtual reality headset that would have dance as a therapy and help people perform physical activities even if they're stuck in a building. Recently, I was in Shanghai. I was on buildings that they were 30 levels up. Performing physical activities in big cities is not easy. But if you have a virtual reality headset and if you're in Shanghai in a high-rise building on the 30th level, you could still perform dance as a therapy. This would also help various different communities in our society, starting from little children going to the elderly. Loneliness is one of the problems that we have with the elderly people, and if we can build these virtual reality AI agents in a way that would help prevent loneliness, that is a step forward. But we have to be careful about what does physical interaction and dance as a therapy, what does it actually help? Is it because the dance itself helps alleviate mental health problems, or is it because you are in a group with people? So these AI agents that we built in the virtual reality headsets, they need to be encouraging further interaction in a dance studio or with groups of people in the park, because I believe that the interactions with other humans is what actually prevents the mental health development, not the act of dancing per se. Maybe it's a positive factor because you're moving, but it's not the only factor that we need to look after. And on that note, I have to end this presentation. I hope to see you in China in the future, and please do um, And on that note, I have to end this presentation. Please remember that my book is coming up in China in the first quarter of 2026. And if you want to connect with me, just type my name in any internet browser and you will find my University of Oxford and my Alan Turing staff profiles, which will provide you with access on how to connect with me via social media or with a LinkedIn. Hope to see you in China in the future.